Hello, everybody, and welcome again to your channel, Thermal Engineering Concept and Principle. This is Professor Ali Tarrad, and I will introduce to you in this episode uh, an important issue related to the Rankine cycle, which is used in power plants for producing electricity. In this part of um, the episode, which is related to the representation of Rankine cycle on temperature entropy diagram. And this diagram is usually used to represent the thermal cycle, and again it will help understanding the processes and the different components of the cycle, and will give you an overall view of these cycles and where can be used and how can we represent the cycle on the TS diagram. Thank you for your support and keep on watching and sharing the content of this channel to achieve our important goals related to reaching and giving the information for the person who needs it free of charge, of course, and at the same time, it will be a useful step to enrich the knowledge in the thermal engineering concept.
Now let us discuss Rankine cycle. Rankine cycle, the thermal cycle, composes of four different thermal processes, and there are four components. We have boiler, turbine or expander, condenser, and pumping system. The objective of this cycle is to convert energy from external source to electricity. Usually, energy is extracted from burning out the fuel, such as fossil fuel, coal, oil, or natural gas. And then the energy of this process is extracted by water, for example, when we are talking about steam power plants, and this water is converted to steam. Usually, the vapor which leaves the boiler is in a superheated condition. This vapor passes through the turbine, and the turbine usually is composed of multi-stages, and it extracts the energy that is stored by the steam and convert it to a dynamic energy where the blades inside the turbine extracting this energy and convert the thermal energy to mechanical energy. And with the aid of a generator, we may convert this rotation energy to electricity. Usually, the fluid which leaves the turbine is in a mixture condition that is composed of about 92 to 94 percent dryness fraction, and that means there is some liquid is leaving the turbine, and this mixture, vapor liquid mixture, is passing through a condenser where it is condensed, and we can achieve this process by passing a cooling water through the condenser, which can be withdrawn from a river, lake, or even a cooling tower. Condensate is pumped by a pumping system which uses a motor with a power supply. Then the liquid is pumped to the boiler. So in that sense, we will get a closed circuit for the working fluid inside this cycle.
In this part of the episode, we will talk about the TS diagram. And as long as we are talking about Rankine cycle, which is used in power plants, usually it is represented on a diagram or graph as shown in this illustration. Usually fluids have a curve. For example, for the steam is represented by the blue curve. To the left is liquid. To the left of this curve, liquid, it is called subcooled liquid, in fact, because its temperature below the saturation temperature of the liquid at the operating pressure. And on the blue line, when we reach the blue line, then we will have a saturated liquid. The dome of the curve, there is a point which occupies the highest values. It is called the critical point, where we have a critical temperature and a critical pressure. To the right-hand side of the curve, where we reach the blue line to the right-hand side, it is called saturated vapor. And to the right of this line or part of curve, we will be in a zone called dry steam. And here we have the steam is superheated steam. And superheating, it means that the temperature of the steam is higher than the saturation value at the operating pressure. To represent the cycle which we have shown in the previous part of this episode, let us assume that the inlet to the pump is subcooled at a temperature T1. And usually there is something called the isentropic efficiency related to the pump, and the temperature will approach T sub 2 isentropic, where we have S is constant. The entropy is constant. In the actual term, the operation through the pump will follow the curve or the line, the black dotted line, to reach a temperature T2, and that will be at a constant pressure, where the inlet at the boiler is T2, and it passes constant pressure, extracting energy, heated up until it approaches the saturated value of the liquid, where here we can get liquid and vapor phases as continuing to heat up the liquid. Then a part of the liquid will be evaporated at P constant, and especially for pure fluids, then we have T constant as well. And approaches a saturated value, which is saturated vapor. And after that, in the boiler, usually it is superheated to a temperature, which is represented by T sub 3. And in boilers, usually the temperature is so high, maybe 560 Celsius or more, and the pressure is high as well. So at T3, then this is the condition where it enters the turbine. And again, in the turbine, if we assume the constant entropy or isentropic process, then the expansion will follow the blue line, and the temperature, the pressure is reduced to a low value. But in a practical, it will follow the curve, the black dotted line with a value of dryness fraction greater than 90%. And that means we have at the exit of the turbine, there is a part of it is liquid and the rest is vapor. Then it enters the condenser at a condition of T sub 4. Here the condensation process is assumed isothermal and P constant. Then the liquid, which is obtained as a result of rejecting energy to the cooling water, for example, which is supplied or provided from a lake, a river, or even a cooling tower. Then it will reach the saturated value, saturated liquid, where usually in the practical power plants, this temperature is reduced to T sub 1 as a subcooled liquid before entering the pump, and that to improve the thermal efficiency of the plant. This is how usually the Rankine cycle is represented on TS diagram. Of course, this is for the simple cycle, but again, it can be used as a guide for the complex Rankine cycle, because usually we have other helpful or assisted components such as heaters, where are used to preheat water before entering the boiler, and can be added to this graph. Now, my friends, we have arrived at the closure for the present video. We passed through Rankine cycle structure, and we have described the components or the major parts of the Rankine cycle, which are represented by boiler, turbine, condenser, and pump. Of course, this is the simple Rankine cycle. It could be more complex by adding water preheater to improve the thermal efficiency of the plant as well, and can be added to the same graph which we have described in the previous part of this episode. Then we move to the TS diagram, as we have described all the processes in the four components: boiler, turbine, condenser, and the pump. We have some information related to the references which are useful for the reader, and you can get them through a link situated in the description box. And if you feel that the short video which have been described in this episode is useful to you and others, please subscribe and share it with your network to achieve our goals from creation of this episode. Bye-bye.